Now that we've done data wrangling in step 3, we're going to perform analysis on our dataset by fitting it into a classification problem to predict successful orders. These are orders which haven't been cancelled or returned. Here we have the handout model set where we've not performed any feature selection or cross-validation. We've trained and tested it along these 14 classification algorithms, and the best one is the XGBoost classification algorithm, which has the highest F1 score. The F1 score aggregates the precision and recall using its own formula. Now, here we've added cross-validation into the mix. Cross-validation is a resampling procedure where the data is split into k number of groups. We can see that it hasn't benefited us in any way at all. The F1 scores are slightly lower than before. So let's move on. Here we've added feature selection without any cross-validation method. Feature selection is when you select only a subset of columns for machine learning so as not to reduce the accuracy of the model by learning irrelevant features. In our project, PyCaret model does that automatically for us by selecting the best permutation of columns. We will see the importance of each column of our final selected model later. Here you can see that we've gotten a slight improvement in our model performance using the F1 metric in the XGBoost classification algorithm. Let's move on. We tried bringing in cross-validation with feature selection, however, it again did poorly. We've even tried to change the folding method to case stratified, which is a different cross-validation technique. However, it does even more poorly as indicated by the table. Now that we have the XGBoost algorithm, the best performing algorithm using feature selection without any cross-validation, here we're building that model again, but as a separate individual model. And here we're going to fine-tune it. This means that we're going to use hyperparameters using a grid search algorithm built into PyCaret tune module. Here we can see that the final tune model's F1 score in the mean section is the best currently. Moving on, here is the plot I was talking about where we can see the weightage each column has been given in our module. The highest weightage is given to the payment method when it is cash on delivery. Now, the reason why you're seeing multiple columns of each payment method because it has been split into different columns using one hot encoding technique so that it can be easily compatible with our classification algorithms. And this is the error plot to give you a better idea of how well the model has performed for each class.